Good evening, everyone. My name is Eric DiMarzio, and I'd like to welcome you back to another Tech Talk in our series sponsored by Remake Labs. Today, we have the pleasure of welcoming Alex Stewart and Sam LaRiviere to give us a brief talk about AWS Cloud Computing. So, without further ado, gentlemen, I'll pass it over to you.
Thanks, Eric. Hi, everyone. Thanks so much for being here.
And a big thank you to Remake Labs for sponsoring this talk. Now, on with the show.
Tonight, we're going to talk to you about cloud computing.
More specifically, AWS Lambda functions.
I'm Sam, and this is my best friend, Alex. Before we get into it, we're going to give you a brief overview of what cloud computing is, Amazon Web Services, and finally, AWS Lambda functions. Let's start with some of the basics about cloud computing.
All right, so cloud computing.
What the hell is even that?
Yeah, Sam, what the hell is even that?
Great question, Alex. Cloud computing is like using the internet as your personal IT department. Instead of storing data on your computer or buying expensive hardware, you access resources like data storage and software online. It's a little like renting space in a massive warehouse that's miles away, instead of cluttering up your garage with storage.
The cloud has a ton of use cases, everything from running video games on portable devices to real-time fraud detection and prevention for financial services to helping healthcare providers access patient information from anywhere, meaning personalized treatments on the fly.
It's why your phone can stream the newest TV series without getting really hot in your hand.
For developers, cloud computing means not shelling out for expensive hardware up front. You pay for what you use, and it gives you access to all kinds of powerful tech, like data storage, application hosting, machine learning, all without managing servers. Also, you can whip up and deploy something in minutes that used to take weeks.
So you can develop an app from a tropical island and still have the tools of a corporate office.
And we love a segue, so speaking of tropical, I think it's about time we start talking about Amazon.
I'm a piranha. Damn, Amazon.
AWS stands for Amazon Web Services. And no, they didn't pay us to talk about them. But hey, if they're offering.
I mean, they're probably busy enough running half of the internet, but yeah, sure, hey, if they're offering.
Wouldn't that be nice? AWS is a powerhouse in cloud computing. It offers a huge range of tools that help businesses and developers build, scale, and maintain their applications, all in the cloud. And the best part, they have a free tier, so you can get started and play around without spending a cent.
All right, so let's hit some of the highlights. First up, we've got S3.
Is there anything software engineers love more than an acronym?
I'm gonna go out on a limb and say maybe rubber duckies.
Got him.
Got him. All right, the simple storage service. This is the cloud equivalent of a bottomless pit for storing files. Basically like a big online hard drive. It's a place to store static files like photos or documents. Within S3, data is organized into smaller storage containers called buckets, which are like folders in that hard drive analogy.
Netflix even uses S3 to store its massive library of movies and shows. They're even able to store different versions of each video file that are optimized to be viewed on different devices and with different internet speeds.
All right, up next, we got RDS. This is Amazon's relational database service. It's for structured data. It's sort of like a giant Excel spreadsheet, so it's perfect for handling customer information and orders.
Netflix uses RDS too. It's great for internal or operational applications like employee management, financial systems, and even metadata about its shows and catalog details and actor info. It's great for any relational data that might be useful for the app, but might not require as much storage as, say, keeping track of information about its millions of users. What do you think they would use for that, Alex?
I think I'm picking up what you're putting down, buddy. I'm going to say DynamoDB, which is Amazon's non-relational database. It's the go-to for quick access to massive amounts of data. Netflix stores its user info there. It's fast, reliable, and ideal for binge watching recommendations. So when your food is getting cold while you're flicking through the recommended for you category for like 3 hours, you can thank DynamoDB for that one. Now, we've been talking a lot about places to store data with AWS, but what about processing data? Where would somebody do something with their data?
I'm thinking the EC2, the Elastic Compute Cloud. It's Amazon's virtual computer service. You're basically renting a powerful computer in the cloud to run programs, apps, and more. And you know who uses it?
Netflix.
That's right, Alex. McDonald's. McDonald's uses EC2 to handle all those mobile orders for fries and Big Macs. If there are tons of orders coming in, it's automatically scalable, meaning more computing power gets added on the fly. If just one user is ordering, it's no problem. But if a bunch of users hop on the app at the same time, McDonald's can handle the heavy demand by creating as many EC2 instances as they need. Each new instance shares the work, so the app doesn't slow down. And since it's auto-scaling, when traffic goes back to normal, the extra instances automatically shut down. This saves costs for Mickey D's and keeps their customers happy.
Sounds like the perfect excuse for my little Big Mac habit.
Right. Maybe you should be scaling down, not up. Scalability joke.
How very dare you?
Okay, now for the main event. Lambda functions. What exactly are they?
Think of them as magic little helper robots that do specific tasks, but they only wake up when you need them. Let's dig a little deeper into why they're so powerful. So first off, Lambda functions are triggered by events, whether it's someone clicking a button, uploading a file, or even a change in your database. Lambda wakes up, runs your code, and then goes back to sleep. No need for a dedicated server hanging around waiting for something to happen. It's the ultimate on-demand worker. It's also cost efficient, and here's where Lambda really shines for developers. You only pay for the time your function is actually running. So think of it like a taxi meter. No passengers, no charge. If your function runs for 300 milliseconds, you only pay for 300 milliseconds, not the entire hour like you would with a traditional server. This is perfect for microservices or small tasks that don't justify an always-on server. And one of the biggest advantages of AWS Lambda is how easily it handles scaling. When traffic increases, Lambda creates new execution environments to process multiple requests at the same time. Instead of starting a new environment for every request, Lambda keeps some environments warm, ready for the next request, so it doesn't have to restart from scratch each time. This reduces delays and keeps things running smoothly. AWS takes care of all this behind the scenes, so you don't have to manage any complex infrastructure or configurations. And finally, Lambda functions are stateless, which means they don't store information between executions. If you need persistence, because let's be real, some things do need to be remembered, you can easily connect Lambda with a specified database. It's like asking Lambda to handle a task and then pass the paperwork to the right service for safekeeping.
So basically, it's like if you had a cleaning robot that only comes out when your place gets messy. It's always ready, but never gets in the way.
Exactly. And it's perfect for tasks that need to happen quickly, like image processing, API requests, or automated workflows. You write the code and Lambda runs it when needed.
Now that we know how Lambda functions work, let's see how they team up with other AWS services to make magic happen. Picture Lambda as that one team member who doesn't talk much, but when they do, everyone's shocked to find out that someone actually knows what they're doing. First up, Lambda and S3. Every time someone uploads a new file to your S3 bucket, let's say a user uploads a high-res photo of their cat to your social media app, Lambda gets triggered like an overworked IT guy on pager duty. It swoops in, resizes the image for different device resolutions, and stores the versions back in S3. So when users load the app on their phones, they aren't downloading a file bigger than their data plan. Lambda handles it all. Scalable, efficient, and with no downtime. No more data limit exceeded notifications when Auntie Cheryl uploads her vacation photos. Next up, Lambda and DynamoDB. Imagine you've built a gaming app with millions of users trying to save their high scores at the same time. DynamoDB is perfect here because it's fast, flexible, and scales like a dream. But what happens when a user smashes their personal best? A Lambda function can snap to action, updating the leaderboard, maybe triggering a push notification to rub it in their friends' faces. Now, let's bring it back to RDS. Let's say your app is managing customer orders in RDS. A new order comes in. How about 10,000 chicken grease face masks from some new startup? It's 2024. Who knows what's trending? You can configure Lambda to wake up, process the order, update the inventory, and send a confirmation email, all in real time. And last, Lambda and EC2. Imagine your app is seeing traffic spikes because your virtual pencil sharpening feature just went viral. Normally, EC2's built-in autoscaling would handle the extra load. But with Lambda, it takes it a step further. Lambda can trigger new EC2 instances dynamically based on real-time traffic, scaling up or down even more efficiently. This makes sure you're not over-provisioning servers or wasting resources. Lambda keeps it streamlined, so you only pay for what you actually use.
So to sum it up, Lambda is like the glue that holds your AWS services together, making sure everything reacts in real time and scales automatically. Whether it's resizing images, updating leaderboards, or dynamically managing servers, Lambda functions are fast, efficient, and tailor-made for modern applications.
And let's not forget, Lambda does all of this while saving you money. Serverless architecture is like hiring a contractor that only bills you for the time you're actively hammering nails. No wasted server resources, no unnecessary costs. So how do you set one up? First, you log in to the AWS console, navigate to Lambda, click on Create Function, give it a name, choose a runtime, and boom goes the dynamite. You're halfway there.
You'll need to set permissions too. You want your function to upload files to S3 or fetch data from DynamoDB? Just specify that in the execution role. That's what defines the permissions that your Lambda function can and cannot do within AWS. It's as easy as, well, ordering from McDonald's on EC2.
There's only one thing left to say. Ba-da-ba-ba-ba. I'm loving it.
To wrap it all up, cloud computing lets you store and access data via the internet. AWS offers tons of services to make it easy, and Lambda is the magic that runs your code without servers.
Just like a helpful little robot that doesn't even judge your Big Mac habit, like my best friend literally just did, in front of a large group of people.
Sorry, buddy. Thanks for sticking with us. Hopefully you learned a little more about AWS and Lambda functions. And if not, well, at least we had a good time.
Here are our references.
And if you have any questions or just want to get in touch, here's where you can find us.
Once again, a big ol' thank you to Remake Labs for sponsoring our talk, and to our wonderful host, Eric. Back to you, buddy.
Thank you so much for that informative talk, and thank you everyone for coming out tonight. We'll see you at the next one.